Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video, the second in the preparation for the CUNY Elementary Algebra final exam, provides worked-out solutions for Sample B. Sample B is similar to Sample A. If you want more detail for a particular question, please refer to the same question number in Sample A. Both samples are found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may therefore differ somewhat from those used by your instructor. This is normal and to be expected. If you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in one way in order to avoid confusion. Occasionally, though, I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Problem number 16 asks you to solve the quadratic equation 6x squared equals 150. The difference between problem number 16 and problem number 15 is that in problem number 16 you're missing the x term. We only have x squareds. So a different strategy will be used. We will use what's called the square root property. And the square root property is if x squared equals some number, call it k, then x will equal either the positive square root of k or x will equal the negative square root of k. Now in our equation, we're almost given an equation in the form from which we can use the square root property. The only thing we have that we don't want is 6. So the way we can get rid of the 6, of course, is by dividing both sides by 6. So the 6's will cross out. Now you can reduce 150 over 6, or if you don't feel comfortable with that, we can do a long division. So 6 into 15 is 2. 2 times 6 is 12. And 6 into 30 is 5. Since there's no remainder, the answer is 25. So we get x squared equals 25. And now we can use the square root property. So we know x equals positive the square root of what we have, positive the square root of 25, or x equals negative the square root of 25. So x equals 5 or x equals negative 5. So we see that corresponds to choice C. Question number 17 asks you to determine the value of x. When they give you a right triangle, as indicated by the little square in the lower left corner, that is a right triangle. And since the side x is opposite the right angle, that is the hypotenuse. The hypotenuse is side C. In the Pythagorean theorem formula, c squared equals a squared plus b squared, which you'll need to use in order to solve for x. So once we know that, it's straightforward. And all we have to do is plug in. C is x, so we have x squared. A and b are interchangeable, so we can place 4 for a or 6, doesn't matter. So I'll put 4 squared plus 6 squared. X squared equals 16 plus 36. or x squared equals 52. Now we can use the square root properties from the previous problem, and we'll get x equals positive the square root of 52, or x equals negative the square root of 52. However, since x represents the length of a side cannot be negative. So in this problem, we will have to discard the negative solution, and we'll be left simply with x equals the positive square root of 52, which now will simplify. So the largest square factor of 52 is 4. So it'll be 4 times 13. We'll give them a divorce, because the multiplication rule says they can live under one roof or under separate roofs when they're being multiplied. And we'll wind up with x equals the square root of 4 times the square root of 13 under separate roofs. And finally, x equals 2 times the square root of 13. And that corresponds to choice B. Problem number 18 asks you to graph the solution to the given inequality. Now on sample A, I go into the solution in much more detail. So if you're not familiar with that, I suggest you go to sample A before you'll be able to make best use of the solution I provide here. So here we have an inequality. By an inequality, we mean an unequal condition. We're going to use the same rules for the most part that we use for solving equations, except when we come near the end, which I'll explain. Now, they want us to graph it, and we'll be graphing the solution on the real number line. One of the choices you see there will be correct. Since the final line in our solution will be not x equals something, but x is less than something, or x is less than or equal to something, x is greater than something, or x is greater than or equal to something, we see we're going to have many solutions. Whatever x, if x is less than, let's say 4, then 3 would work, 2 would work, etc. So that's why you see a line with an arrow indicating the solutions to the problem. So we'll begin by putting the x's on one side, just like we would in an equation kind of situation. So I could put the x's on the left side or the right side, but I'm going to put the x's on the right side because that way you'll have positive x's. If you want to see what happens when you get negative x's, if you put the x's on the left side, then once again refer to the sample A video. So I'll subtract 2x from both sides, and that will give me negative 3 is greater than or equal to 3x plus 6. I'll continue isolating the x by subtracting 6 from both sides, and that will give me negative 3 take away 6 will give me 9 negatives greater than or equal to 3x. I want to solve for x, not 3x, so I'll divide both sides by 3, and that will give me, the x's will cross, the 3's will cross out here rather, and that will give me x on the right and negative 3 on the left. Now they want you to solve for x, not for negative 3, but if something is greater than something else, then that other thing must be less than. So in other words, if the thing on the left is bigger than the thing on the right, then the thing on the right must be less than the thing on the left. So this is our solution. X is less than or equal to negative 3. And if you look at the graph there, you'll see that that will correspond to choice C. Because over here you see negative 3. X is less than that, so that's why we're shading to the left. And since it's equal here, we have to fill in the circle. So circle must be filled. And once again, the answer is choice C. Problem number 19 deals with function notation. Now, in function notation, you're given f, which is a rule. In this case, the rule is to multiply 5 times x squared, subtract 8x, and add 2. You're given an input, which is x, and you're given the output, which is read f of x. So here where we have f of x, that's the output. That's the result of multiplying and subtracting what you see on the right side of the equation. Now in general, the input is x, but here they want to know what is f of 2. So they have a specific input they're giving us, so they want us to evaluate f of 2. So all you do is substitute x with 2. So we'll write f. The function names are usually italicized, so that's why the funny looking f. And they want the input to be 2. And we'll replace all instances of x with 2. Now I like to place the variable that I'm replacing with an empty set of parentheses before I begin, just so I stay out of PEMDAS trouble. And now I'll just plug in 2 and 2. And now all we do is use our order of operations to figure out the answer. So f of 2 will equal, let's see here, 5 times, we have an exponent. The exponent will go first here. So 5 times 4. Now we'll do our multiplication. So we'll get 5 times 4 is 20. We're not subtracting. We are multiplying the 8. So 8 times 2 is 16. And we'll finish off by doing the subtraction and the addition left to right. So 20 take away 16 is 4 plus 2. And so the final answer will be that f of 2 equals 6. And that is choice C. Problem number 20 asks you to graph the equation 5x plus 3y equals negative 15. Now this is the equation of a straight line, and the way you know that is when you have some number times x plus some number times y equal a number, that is the equation of a straight line. And when it's in this particular form of a straight line, namely standard form, it's very easy to graph using the intercepts method. To use the intercepts method, you need to know what the intercepts are. There are 2 intercepts. The first intercept is referred to as the x-intercept, and it's where the graph crosses the x-axis. You will not know what the x value is, but you will know what the y value is. It has to be 0, since you have not gone above or below the x-axis. And similarly, the point where the graph crosses the y-axis is referred to as the y-intercept. And you know that the x will be 0 there because a point on the y-axis has not gone left or right of the y-axis, and the y will be whatever it will be. Now we will be able to have identified 2 points, the 2 intercepts, and 2 points define a unique line. So let's find the x-intercept first. We know at the x-intercept that the y is 0, so we'll plug in y with 0. So 5x plus 3 times 0 equals negative 15. Solving, we get 5x, 3 times 0 is 0, equals negative 15. Dividing both sides by 5, we get x equals negative 3. So now let's find the y-intercept. The y-intercept, at that point, we know the x will be 0. So when we plug in, x will be 0. And then we'll add in 3y equals negative 15. 5 times 0 is 0, so you'll get 3y equals negative 15. Dividing both sides by 3, we'll get y equals negative 5. So we now have our two coordinates, our two intercepts. We have our x-intercept at negative 3, and we have our y-intercept at negative 5. So let's look at the graph. So which has an x-intercept of negative 3? Well, we see A does not. It's at negative 5. B doesn't. C doesn't. D here has an x-intercept of negative 3. In fact, it's the only graph, so clearly D must be the answer. Just checking here, the y-intercept, we see that the graph does cross the y-axis at negative 5. Now, if you're having trouble reading the numbers here, then you just count the boxes to see whether we're at negative 5 or negative 3 or whatever. Problem number 21 asks you to find the equation of a line passing through the given points. And they want you to write it in slope-intercept form. Now you know this is possible since 2 points uniquely define a line, so you will be able to find the equation. Slope-intercept form is in the form y equals mx plus b, where the m and the b are the letters you're going to have to find. The m is the slope, and the b is the y-intercept. Now, they did not tell you the slope nor the y-intercept explicitly, but they gave you enough information that you can find it. We can find the slope using the slope formula. So we need to identify our 2 points so we plug in properly. So it doesn't matter which point you refer to as the first point and which point you refer to as the second point. So let's call this the first point. And let's call this one the second point. And now, if you remember the slope formula comes from the rise over the run, and it's the difference in the y's divided by the difference in the x's, the rise over the run. So now we'll plug in negative 8 minus 7 over x2, which is 2, minus x1, which is negative 1. Just make sure you're not careless when you do this. That gives me negative 8 take away 7 is negative 15. 2 take away a negative 1 is 2 plus 1, which is 3. And so the slope equals negative 5. So now we can plug in. So we'll write y equals mx plus b. We know the slope, so we can plug in negative 5 for m. And all we have to find is b, the y-intercept. Now, they did not tell us b, but they told us 2 points on our line, and the equation we're constructing now determines every point on the line. 2 of them they gave us, so all we have to do is plug in one of the points they gave us for x and y here. You can plug in either point. Generally speaking, I like to plug in the point that has the numbers are smaller or has fewer negatives. That's up to you. Let's plug in the first point. So the first point is negative 1, 7. So the 7 is the y. So we'll plug that in here. And the x is negative 1. Now we can solve for b. So we have 7 equals 5 plus b. Remember, when you multiply and the signs are the same, the result is positive. We'll subtract 5 from both sides, and we'll get b equals 2. So the equation that they're looking for in slope-intercept form is y equals negative 5x plus 2. So that corresponds to choice A. Question number 22 asks you to find the equation of the horizontal line passing through the point negative 5, 3. So I've drawn a pair of coordinate axes, and I've labeled the point negative 5, 3, and I've drawn the horizontal line through that point. So which choice is the correct equation? There are a couple of ways to go about doing this. One way is to realize that no matter what the x, every point has the same y. If you look across our horizontal line here, you'll see the y is the same always, regardless of what the x is. And so the x does not matter. Well, if the x does not matter, it should not be in our equation. And there's only one choice where the x is not in the equation, and that would be choice C. Now let's see whether that makes sense, that equation, y equals 3. Well, at this point y is 3, this point y is 3, this point y is 3. So that's all you have to say about that line, that y is 3, and that describes the line perfectly. Alternatively, you could look at the problem this way. Since the slope of a horizontal line equals 0, the equation y equals mx plus b becomes y equals 0 times x plus b because the slope is 0. The x drops out, and you're just left with y equal to a number b, which turns out to be its y-intercept. So you see once again that the x drops out, and that the answer must be choice C. Problem number 23 asks you to find the slope and the y-intercept for the given equation. Now, to provide that information, the equation has to be in the slope-intercept form. So we see it's not. We need to solve for y. So let's do that. We start with 6x minus 7y equals 35. We want to isolate the y, so we'll remove the x term. And that will leave us with minus 7y equals, now you can write 35 minus 6x, or you could also write negative 6x plus 35. You'll see that these are the same. I have a negative 6x with what I just wrote, negative 6x here, positive 35, positive 35. This way it more closely resembles the slope-intercept form. I'll now divide both sides by negative 7 to solve for y. And if you remember from the sample A video on this problem, to divide the right side by negative 7, that's the same thing as dividing each term by negative 7. So the negative 7's cross out, and we're left with 6x over 7, because the negative divided by a negative is a positive, and 35 over negative 7 is negative 5. And so the slope is 6/7, and negative 5 is the y-intercept. So if we look at the choices, we see the answer is choice A, with a slope of 6/7 and a y-intercept of 0, -5. Problem number 24 says that if 6 beads weigh 48 grams, how many beads weigh 72 grams? So they want to know that given the relationship that 6 beads weigh 48 grams, how many beads will weigh 72 grams? This kind of problem is called a proportion. They want to know, based on the relationship between 6 beads and 48 grams, how many beads would you need so that they would weigh out to 72 grams. So you set up a proportion as follows. You say that 6 beads is to 48 grams as, they say how many beads, so this will be our variable, as x beads are to 72 grams. And you have to put the units in the same order on both sides. So notice I have beads on the top on both sides, grams on the bottom. Now you cross multiply, so we'll get 48x equals 6 times 72. We'll divide both sides by 48. The 48's cross out, so you'll get x equals. Now you can do some crossing out on the right side too. You know that 6 and the 6 goes 1, 6 and the 48 goes 8. You know 8 and the 8 goes 1, and you know 8 and the 72 goes 9. So you're left with 1 times 9 on the top, which is 9. And you're left with just 1 on the bottom, so you don't need to write that. So the answer is 9, and that is choice B. Problem number 25 is a percent word problem. In 2010, there were 50 fish in a pond, and in 2011, 1 year later, the number of fish decreased by 20%. So they want to know how many fish were in the pond in 2011. And clearly, we'll have fewer than 50 fish since the fish decreased by 20%. Now, in sample A, I taught you 2 methods. One was the formula method, when I said we power it up, and the other was the proportion method. So if you want to know how to do the proportion method, refer to sample A. And if you want more details for the formula method, which we'll use here, also refer to sample A. So the first thing we do when we have a percent word problem is we power it up. So the formula is P times W equals R. So we power it up, where P is the percent, and it's the percent of the whole, what you start with. So in this case, the whole would be 50. We started with 50 fish in the pond, and the result is what you get after you apply the percent to the whole. Now, you need to remember that P and R must refer to the same quantity. So in this example, since P is 20%, but it's the amount of the decrease, R must also decrease. R must also refer to the amount of the decrease. So now we just plug in. They told you that P is 20%. Now in the formula you have to convert the percent to a decimal. You cannot use percents. And the way you do that is to move the decimal point 2 to the left. So 20 becomes 0.20, but you don't need the 0 at the end, so you can just write 0.2. W is 50, as we said. And if you multiply the two together, you're going to get R equals 10. Now keep in mind that R is the decrease. They want to know the amount of fish that were left in the pond, not the amount of the decrease. So what we're going to have to do is subtract. So the amount of fish in 2011 will be equal to the amount of fish we started with in 2010 minus the amount of the decrease. So the amount of fish will be 50. That's what we started with. Take away 10 to decrease. And our final answer will be 40. And that corresponds to choice D. I hope you have benefited from this video. And good luck.